Everybody, today we're looking at rate of change, and it's the start of the calculus topic, which is quite exciting. So to start with, we're going to look at a linear function, and here we can see the rate of change quite easily. So the rate of change describes how one variable changes with another. So in this case, as x increases by 1 unit, y increases by 2 units. And when this occurs, we say that the rate of change of y with respect to x is 2. So, fairly simple little concept. It gets a little bit more complex when we look at a curve, because as opposed to our linear function where it doesn't really matter where we start, it's always going to increase 2 units for every unit. Y is always going to increase by 2 units for every unit that x increases. With a curve, this isn't the case. In some points, it's going to increase. In some cases, it's going to decrease. In some cases, it's going to increase by a lot. In some cases, it's going to increase by a little. So let's have a look at this function here that I've drawn. At point A, as x increases, y also increases. At point B, as x increases, y is now decreasing. At point C, as x increases, again the y value increases. So in different points on the curve, the function is doing different things. So let's have a look at slope at a point. So by finding the slope at a point, we can determine the rate of change. At point A, we can see that the rate of change would be negative. As x increases, y is decreasing. And for B, as x increases, y increases. So the rate of change would be positive. If y is increasing as x increases, the rate of change is positive. As if y decreases as x increases, the rate of change is negative, or it decreases. Now the lines I've drawn in red are called tangents, and they indicate whether a function's increasing. They indicate whether the slope at a point is increasing or decreasing. Okay, so let's look at the features of a curve. So if we have a look at as x tends to negative infinity, we can see that y is also going towards negative infinity. And that's what this first statement here says. And that would be the global minimum of this function, because that would be where the function is at its most negative value, or where the y value is at its most negative value. Point A, which is this point up here, is the local maximum of the function. It's not the global maximum, because that would be over here, but it is a maximum in the locality of itself. And we can see here that if we draw a tangent, the slope would be 0. It's going to be a horizontal line. From A to B, from here to here, the slope is decreasing at an increasing rate. At this point, the slope is 0, and as it continues along the function, the slope is getting steeper and steeper and steeper until it reaches point B. At point B, that changes, and the slope the function is still decreasing. As y increases, as x increases, y is still decreasing, but it's now decreasing at a decreasing rate until it gets to here where the slope again is 0. The curve is concave down from wherever D is all the way to B, and it's concave up from B to E. At B, we call it a point of inflection. It's where the concavity changes. Point C is a local minimum, and the slope at C, I don't know why that says B. Let me fix it. The slope at C is 0. As x tends to positive infinity, y also tends to positive infinity, where the global maximum is. Points A and C are known as stationary points because the slope at both of those points would be 0. Let me mark in the slope over here. Slope. Slope. Yeah. Okay, and last but not least, the special case, a horizontal point of inflection. The tangents I drew earlier only touch the curve at a single point. The exception of that is at a point of inflection, whereas we can see here it moves all the way through. We can see here it moves all the way through the point and through the curve. So again, looking at A, we can see that at that point the function is increasing, or the slope is the function is increasing at a decreasing rate. So here the slope is very steep, here the slope is getting less steep, and here the gradient will be 0. Then at point C, at the point of inflection, where the concavity changes, the slope starts increasing again. So from 0 to some value to some greater value. Once you get that your head around that, and that stationary points can either occur at horizontal points of inflection. We should note here that even though that's a point of inflection, it's not a horizontal point of inflection, so the slope is not 0 at that point, but the slope is definitely 0 at the maximum and minimum points. So a stationary point can be a horizontal point of inflection, a maximum, or a minimum. There's some quite cool apps, I think GeoGebra is one of them, that can show you the slope at a point and how it changes. I might try and do one of those for you in class. Alright guys, there's a quick video on rate of change, and hopefully we'll get started into the calculus stuff soon. Thank you everyone.